Leetcode question 19. Remove nth node from end of list. Given the head of a linked list, remove the nth node from the end of the list and return its head. So example 1. We are removing the second node from this linked list, and we remove this node is 4. In order to remove it, so basically we find its previous node, which is the node 3, and then we change previous node's next node from this node 4 to the node 4's next node, node 5. So in that case, node 3 points to node 5 instead of node 4. So in that case, we successfully removed the node 4. So how to solve this one? So basically the idea is how to get the nth node from the end of the list. If it's the nth node from the beginning of the list, then that's easy. We just move from the beginning and just count, okay, that's the nth node we encounter. However, for this problem, the brute force way is, first we are trying to get the total length of the linked list by traversing through all the nodes in this linked list. And then we just do another loop to get the length minus k node from the beginning. So that's the brute force way. Can we just solve this one in one loop? The answer is to use 2 pointers. So basically, it's another common technique used in the linked list, fast pointer and the slow pointer. We are using 2 pointers. So this fast pointer first move n steps, so move n nodes, and then this fast pointer move together with the slow pointer. So in that case, the slow pointer falls behind the fast pointer by n nodes. When fast pointer reaches the end of the linked list, slow pointer would reach the nth node from the end. So basically the idea is simple. So we have 2 pointers, slow and fast. So when initially slow pointer is not moving, but fast pointer is moving. And we are making sure the distance between slow pointer and fast pointer are n nodes. So in that case, when we continue moving fast and slow pointer together after the fast pointer reaches the first n nodes, in that case, when the fast pointer reaches the end, the slow pointer reaches the nth node from the end because the distance between those 2 pointers is n nodes. So that's kind of the idea. Common techniques for linked list, slow and fast pointer. When we delete the nth node from the end, what we are doing in order to delete the nodes is, okay, the nth node from the end, that is the previous node of this nth node from the end. We point this one directly to the next node, which means the n-1, the n-1th node from the end. So in that case, we just bypass the nth node and thus remove the nth node from the end from the linked list. So in that case, what we actually need to know is this n+1th node from the end. So how to do that? We can select the slow pointer from the dummy node, which means, okay, for the starting position, slow pointer starts from the dummy node. Dummy node is also a common technique for solving linked list. So dummy.next is just the head. So this is the starting position for this slow pointer. And then fast pointer still starts from the head of the linked list. In that case, when the fast pointer moves n steps, the distance between the slow and the fast pointer is just n+1. And then they move together. When the fast pointer reaches the end, the slow pointer stops at the n+1th node from the end. So that's the idea of solving this problem. Let's start coding. So in this case, we have a dummy node. So dummy node. So the dummy node, dummy.next is just the head. And then we have 2 pointers, fast and slow. So initially, the fast pointer is just the head of the linked list, and then the slow pointer, just the dummy. And then we first move this fast pointer n steps. So in that case, well, this n is greater than 0. Fast.next, and then n minus 1. So in that case, we move this fast pointer by n nodes. And then the next step is move slow pointer and the fast pointer together. So in that case, when fast pointer reach the end, slow pointer reach n plus 1 node from the end. Okay, so in that case, well, this fast in that case, we slow, and the fast is just slow down next, fast down next. That is when the fast pointer reach the end, the slow pointer will stop at n plus 1. And then after that, it just, we need to delete. So in that case, slow down next, just slow down next, down next. So slow is the n plus 1 node from the end. Slow down next, we just set the next node of the slow pointer to the n minus 1 node from the end. And then in the end, we just return dummy.next. Okay, this